Now we come to a main question. Is there a main effect due to a particular factor? So this is question number 2 in the two-way analysis variance section. And remember, the two questions in this section: does one factor depend on the level of another factor? And then if there is no interaction, is there a main effect for our particular factor? And so we did this in a previous video that we looked at the partial F test and determined that there were no cross terms, so we are okay. So let's go back to this question. Is there a main effect for majors? That is, if you look at the average score of this particular class, does it differ substantially for different majors? And so again, we cannot answer this question if there is no interaction. So we determined there was no interaction, then our current model just has x1, x2, x3, x4, and x5 in it. Remember, x1, x2, x3, x4 are the majors, and x5 is the gender. And so we cannot proceed if there was. So let's go on to question number 2A. Are there differences between the major score? And we could set up this 3 different ways. The null hypothesis could be there is no main effect to the student's major on scores, versus the alternative, there is a main effect to the student's major on scores. Another way of saying that is beta 1, beta 2, and beta 3, and beta 4 is 0. We'd still have beta 5 because that's gender. And the alternative hypothesis, at least one of the coefficients is non-zero. And again, you could say that again, we can eliminate those predictor variables, and the alternative would be at least one of the predictor variables is okay. So let's go ahead and take a look at our data. Here's our data down here. And here are the various scores. And so first of all, we want to run a full model. And we want to fit the regression model between score and our continuous predictors are all of our predictor variables. I've got an extra gender in there. But now, remember, we better check to make sure we don't have any cross terms in there. So this is just a hint to go ahead and check your model to make sure that there is no cross products terms or interaction terms down here. So we're okay. So we'll go ahead and run the result, and we find our standard error, degrees of freedom, and our mean square error, and this will be our full model. And then let's go ahead and run our reduced model. And so what we're saying is we're going to get rid of everything but gender. We're getting rid of the major bio. We're getting rid of that. And while I'm here at this model, I better do some storage and graph our residual plots, and let's take the residuals versus the variables. So we want residuals versus each predictor. Well, there's only one predictor left, and that's gender for female. So we want to do that. And so we go ahead and do for our reduced model, we get the square error, the mean squared error. If we take a look at the residuals, and I thought I had hit the I must not have. I should do the 4-in-1 plot. A little extra time in this video because of that. So we get this. It looks like a normal probability plot's okay. And the histogram, well, maybe. But anyway, the versus fit. And by the way, I went ahead and did a probability plot 0.487, so we don't have to do that. You should always do the plot. So anyway, let's go ahead and calculate our partial F statistic. Remember, it's the sum squared area reduced, so they're full, degrees of freedom. And so if we take a look at the reduced, 34,1,628. That's not the one. This one here, because they just have gender only. 3341,628 and 1365 and 25 degrees of freedom. That's all in the blue. And then the full would be all of them, all 5 of the predictors, and I get 25972 and 21, 25972 and 21, and the mean square error is 12046 right there. And I plug that in to get 1.84. Go to my probability distribution plot. I get a p-value of 0.1589. My conclusion is I cannot reject the null hypothesis. So I conclude that those predictors are not necessary. So it doesn't give me sufficient evidence to reject the null hypothesis. Therefore, is not evidence to say there's a difference between major's average score. And so there's no main effect due to the student's major on score. So it's not the major, at least from this data set, that causes the difference between the different scores. Okay, next time we're going to look at whether gender has an effect on their